Section 6.2, Adding and Subtracting Rational Expressions. Objective 1, Adding or subtracting rational expressions with common denominators. So what that means is you're going to be adding and subtracting fractions with variables that have the same denominator, or the bottoms are the same. Now when the bottoms are the same, we can go ahead and just add straight across and then simplify afterwards. So this negative goes to the 16. Now once they're the same on the bottom, we can go ahead and combine the tops. So we have 8y minus 16 over y minus 2. You always want to try and simplify as much as you can. Now we notice 8y and 16 have 8 in common, so we can go ahead and take that out. So we have y minus 2 left over y minus 2. Now you can see that the y minus 2's are identical, so we can cancel those out, and we're just left with 8 over 1, or 8. Alright, part B. So as you notice, they have the same denominator, so we're good to go ahead and add them, or subtract them. So remember that this negative goes to the whole thing that's over here. So we have 3y minus 6 over y squared plus 3y minus 10. Now you're always going to want to try and take it one step further. Look for a GCF. Let's see if you can factor a trinomial. So we could do both. There's a GCF on the top, and that's a factorable trinomial. So the top, we take 3 out. We're left with y minus 2. And on the bottom, we can factor that. Different signs. We can go ahead and put y and y. And we need two numbers that subtract to 4 that multiply to 10. That's, excuse me, not 4, 3, which is 5 and 2. So 5 and 2. A lot of the times, the factors you're going to get, if you can factor it out, most of the time you're going to get two of them that are matching. Just like here. Most of the time you're going to get two that are matching when you factor, so that's actually going to help you factor it out. Now we can go ahead and cross some things out. So we cross out the y minus 2, and we're left with 3 over y plus 5. Objective 2. Now we're going to be adding with unlike denominators. So we need to find the LCD first. So that's what we're going to do here, because it's going to help us later on when we have different denominators and finding the LCD. So LCD, remember, is the least common denominator. Let's take a look at our first one, A. So we have 1 over 6y and 3x over 4y plus 12. So the first thing we want to do is factor out the denominator. So we have 6 times y, and then we can take the 4 out of here. So that's 4y plus 3. So now let's take a look at all the numbers individually. Each factor, not term, we're going to look at each factor. So let's take a look at the numbers. We have 6 and 4. Well, what those have in common is 12. And then we have y. And then this y plus 3 left over. Because y plus 3 is different than y, you need to add it on. Let's take a look at our second one. We only want to look at the denominator, so we're going to factor each denominator. So we have x plus 3, x plus 1, and then we have x plus 7, and x plus 3. So you see how they both share an x plus 3? That means we only need to write it once. And then this is x plus 1 and x plus 7. Those are different, so we have to write them individually. So we have x plus 1, x plus 1, and x plus 7. So that would be our LCD. Now, last one, C. Let's take a look at only our denominators. So we have 5x squared minus 5. So we can factor that down. They both have a 5 in common. We have x squared minus 1. And we can keep factoring because x squared minus 1 is a perfect square. So that's 5 x plus 1, x minus 1. Next, we have x squared minus 2x plus 1. So we can factor that out into a trinomial, which is x minus 1, x minus 1. So let's take a look at all the numbers on the outside. There's 5. And then you see they share this x plus, excuse me, nope, they don't share, they share x minus 1. Pretend I never said that. They don't share an x plus 1. There's nothing here, so we need to just write it down. And they do share an x minus 1, but they only share one of them. So for those two, we're going to write it once. And then we still have this x minus 1 left over, so we do have to write it again. So our LCD is 5, x plus 1, and x minus 1, x minus 1. Now you're not going to get something ridiculous like that for the test or for the homework, so don't worry about that. Alright, moving on. Now we're going to take what we just did and apply it to rational expressions. So the first thing we want to do when we're adding and subtracting rational expressions with unlike denominators, we want to factor everything. Top, bottom, every single thing you can factor it out. Make sure the expressions have the same denominator. If it doesn't, find the LCD. Apply the LCD, add the numerators, simplify, and be sure to put back the LCD at the end to fully simplify. You only put the LCD back when you're adding and subtracting rational expressions. Now, this you do if you're doing it my way by clearing out the fractions. If not, if you're doing it the other way of getting the same denominators, then you don't need to put it back. Alright, example 3, part A. So I'm going to show you both ways. A. Nope. So one way is finding the LCD. Well, you're going to do that regardless of which way you do. So let's find the LCD. If you don't know it, multiply the two numbers together. What's 7 times 6? It's 42. And then you see how they both share an A, so that means they need to both have an A. Now, that is you do regardless if it's your first or if you're doing my way or your way, it doesn't matter. You always want to take that first step and find the LCD. So this is method 1. This is the way we're used to seeing it. This is how we usually treat fractions. So we have 15 over 7a plus 8 over 6a. Now, we need it to look like 42a. So in order for it to look like 42a, this needs to multiply by 6, and this needs to be multiplied by 7. So you do 6 times 15, which is 90, over 42a, plus 56 over 42a. Now that they have the same denominators, we can go ahead and add them, and when we do, we get 146 over 42a, and we can simplify that down into 73 over 21a by dividing by 2. So that's method 1. It's a great method, it's quick, but later on in chapter 6, we're going to do something called clearing fractions. So that's why I want you to use this method for the entire section, so you don't get confused within the two methods. For B, C, D, and every single example after that, I'm only going to be using method 2, but I did want to show you method 1. So method 2, the method that we are going to use. So method 2, we already know the LCD. It's 42a. So that means we're going to multiply every single thing by 42a over 1. So what that means is it's 42a over 1 times 15 over 7a plus 42a over 1 times 8 over 6a. And then we're going to cross simplify. So when we cross simplify, we're going to look for things diagonally that they share. Well, they share an a, and 42 and 7 go together 6 times. Now they share an a, and 42 and 6 go together 7 times. Now let's write what we have left over. So what we have left over is 6 times 15, which is 90, plus 7 times 8, which is 56. So we add those two together, we get 146. And now, only when you add and subtract, when there's no equal sign, nothing like that, only if there's adding and subtracting expressions, you put it back under the LCD of 42a and simplify to 73 over 21a. Now, it might seem longer right now, but if you get used to this method, later on in chapter 6, it'll be a lot easier and a smoother transition into equations. So from now on, we're only going to be doing method 2 from here on out. Alright, part B. Part B is 5 over 2x minus 6 minus 6 over 6 minus 2x. So as you see, they kind of look the same. Remember where I told you if they kind of look the same, they probably are the same. So let's switch this around. So we have 6 minus 2x. Well, that's the same thing as negative 2x plus 6. We take the negative out, which gives us 2x minus 6. See, they are the same. So now we're going to replace it right here. So we have 5 over 2x minus 6 over negative 2x minus 6. Now they still all the same thing. You see this negative negative? What happens when you have two negatives together? They become a positive. So we have 5 over 2x minus 6 plus 6 over 2x minus 6. They're the same denominators, look there. We didn't have to find the LCD. So we add the tops, we get 11 over 2x minus 6. Now we always need to see if we can take it further. Look for a greatest common factor, see if you can factor it with the trinomial or if it's a difference of two squares, and we can take it one step further. The bottom has 2 in common, so we can do x minus 3. And that is the final answer. It needs to be simplified completely in order for it to be correct, so you do need to take that extra step. Alright, part C. So C states we have 4 over x squared minus x minus 6 plus x over x squared plus 5x plus 6. So we want to factor out everything. Now factoring out everything in this case means only the denominators. So we have 4 over x minus 3, x plus 2, plus x over x plus 3, and x plus 2. Now, after we factor out everything, we want to find the LCD. The LCD is, so we have this 1x minus 3. There's no other ones on the other side, so it's x minus 3. And you see how they share this x plus 2? So since they share it, we're only going to write it once. And then we just have this x plus 3 left over. So the LCD is x minus 3, x plus 2, and x plus 3. Now we're going to multiply everything by our LCD. You can do it using method 1. You can do it that way. But from now on, I'm going to do method 2 because it's going to help you out later on in the chapter. By all means, still use method 1. I'm just showing you so you can keep at it and it's something that you're always going to see. So we multiply everything by the LCD. We have x minus 3, x plus 2, x plus 3 over 1 times 4 over x minus 3, x plus 2, plus our LCD of x minus 3, x plus 2, x plus 3 over 1 times x over x plus 3, x plus 2. Now we're going to cancel out things diagonally that are identical, so x minus 3, x plus 2, x plus 3, x plus 2. Let's write what we have left over. So what we have left over is x plus 3 times 4 plus x minus 3 times x. We're going to distribute. So we have 4 times x is 4x, 4 times 3 is 12, plus x times x is x squared, x times negative 3 is negative 3x. Let's combine like terms and put it in order. So we have x squared plus x plus 12. And that's all over our denominator of x minus 3, x plus 2, and x plus 3. Now let's see if we can factor out that numerator. So since they're the same signs, we're going to be adding. Let's list the factors of 12. We have 1 times 12, 2 times 6, and 3 times 4. Since they're both the same signs, there are no two numbers that add up to 1. If they were different signs, we could, but since they're the same, you leave it as is. So our final answer is x squared plus x plus 12 over x minus 3, x plus 2, and x plus 3. Alright, part D. We have 7 over x minus 1 plus 10x over x squared minus 1 minus 5 over x plus 1. So let's factor out everything. The only thing that needs factoring is this. It's a difference of 2 squares, so we have x plus 1, x minus 1. Now we want to determine the LCD. Alright, the LCD is, you see how they both share an x minus 1? So we write it once. And you see how they both share, again, an x plus 1. So we write it once. And you see how there's no more terms, or excuse me, no more factors left? That's our LCD. So we're going to multiply everything by x minus 1, x plus 1. So we have x minus 1, x plus 1 over 1 times 7 over x minus 1 plus, wrong color, that's fine, x minus 1, x plus 1 over 1 times 10x over x plus 1, x minus 1. As you see, I put the factored form in. You always put the factored form in when you're working with stuff. And that's minus our LCD, x minus 1, x plus 1 over 1 times 5 over x plus 1. Now we're going to cancel stuff out that is identical. So x minus 1, everything here, and then x plus 1. Let's write what we have left over. So we have x plus 1 times 7 plus 10x minus x minus 1 times 5. We need to distribute everything. So we have 7x plus 7 plus 10x minus 5x minus 5. You notice I kept that in parentheses. I kept that in parentheses because of this minus right here. That means we have to change all the signs. So we have 7x plus 7 plus 10x minus 5x plus 5. Now we want to combine like terms. So we have 7x and 10x is 17x. 17x minus 5x is 12x. And then 7 plus 5 is 12, so plus 12. And then that's over our LCD of x minus 1, x plus 1. We can go ahead and factor the top. They both have 12 in common, so we're left with x plus 1 over x minus 1, x plus 1. Let's cancel like terms, so x plus 1, x plus 1. And we're left with 12 over x minus 1. So that's it for this video.